And welcome to Otten Math. In this edition of Otten Math, we're going to handle both a lesson on solving radical equations as well as take on some practice problems solving radical equations. Okay, so we're going to go over the steps for solving radical equations and also the steps for solving equations with the rational exponents. There are really just two slides. That's why I'm combining both the lesson and the practice. So we're going to go through the steps for each. And I'm going to solve a problem while we go through that. So the first is to write the equation down. Very simple. I have square root of 5x minus 9 is equal to 11. Second is to isolate the radical on one side. Now in this case, this radical is isolated. It's all on its own on one side. But I might have some value or some equation that looks like this, and now I'm going to need to use algebra in order to isolate my radical. So in this case, I'm going to multiply both sides by 4. I get the square root of 5x minus 9 plus 3 is equal to 44, and then I subtract 3 from both sides. Square root of 5x minus 9 is going to be equal to 41. So now I have an isolated radical, and I can start working on isolating the x value. I'm trying to solve for x in this case. But first, write the equation. Second, isolate the radical on one side. In this case, I've already done that. It's already there's no additional steps I need to make. So I'm just going to rewrite my equation. Square root of 5x minus 9 is equal to 11. Then I like to convert, this is my process, convert the radical to rational notation. And this gives me 5x minus 9 to the 1/2. So the square root of 5x minus 9 is the same as, in parentheses, 5x minus 9, end parentheses, to the 1/2. Fourth step, is to raise the term with a rational exponent, which is this value, to the reciprocal of that exponent. So the reciprocal of 1/2 is going to be 2 over 1. So I'm going to raise 5x minus 9 to the 1/2, and I'm going to take that all to the 2 over 1. And while I square, in this case, the left-hand side, I also have to square the right-hand side. 5x minus 9 to the 1/2 and then to the 2 over 1, I use the power of a power property, and I end up with 5x minus 9. I square the right-hand side is equal to 121. And then I solve the polynomial, or I solve the equation. 5x minus 9, I add 9 to both sides. 5x is equal to 130. Now x is equal to 26. All right, second and last slide. Steps for solving equations with rational exponents. Again, first I want to write the equation. I skip the process of converting to rational notation because it's already in rational notation. I need to isolate the term with a radical or rational exponent. In this case, I'm just going to multiply both sides by 7, and I have x plus 9 to the 3/2 is equal to 49 times 7. So this is going to be equal to 343, if I'm not mistaken. 343, x 49 times 7, so 40 times 7 is 280, plus 63 gives me 343. Now I'm going to raise the radical, or the value or term, with a rational exponent to the reciprocal of the exponent. Reciprocal of this exponent value is 2/3. So I say x plus 9 to the 3/2 raised to the 2/3. At the same time, I need to raise is equal to 343 now to the 2/3. X plus 9 taken to the 3/2 then to the 2/3, again using my power of a power property, leaves me with x plus 9 to the 1, which is the same as just x plus 9. And that's going to be equal to 343 to the 2/3. Now I ask myself, are there any perfect cubes in 343 that are equal to 343 or factors of 343? And if I'm not mistaken, 7 is going to be a cube root of 343. So now I have x plus 9 is equal to 7 now squared. So I've taken the cube root of 343, leaves me with 7 squared. And I have x plus 9 is equal to 49. Subtract 9 from both sides, x is equal to 40. Okay, so let's go on to do some practice problems straight away. So I'm combining the lesson and the practice. Check whether the given x value is a solution of the equation. All right, so I have 7 square root of x plus 1 is equal to 7. X is 36. Square root of 36 is equal to 6 plus 1, that equals 7. That's correct. Second problem, I have square root of x plus 1 plus 3 is equal to 6. X is equal to 8. And the square root of 8 plus 1 plus 3 is equal to 6. Square root of 9 plus 3 is equal to 6. 3 plus 3 is equal to 6. And that checks as well. All right, second problem, solve the equation, check your solution. I have the square root of x is equal to 6. I'm going to rewrite this in rational notation. I have x to the 1/2 is equal to 6. I take x to the 1/2 to the second power. So x to the 1/2 to the 2 over 1. At the same time, I'm going to take 6 to the 2 over 1. X to the 1/2 to the 2 over 1 is equal to x to the 1, which is just equal to x. And 6 squared is equal to 36. Second problem, square root of x plus 3 is equal to 7. Okay, in this case, I need to isolate my radical on one side of the equation, so I subtract 3 from both sides. Square root of x is equal to 4. I convert this to rational notation. Square root of x is equal to, remember this is unstated, this is 2 as the index, 1 is the power, rewritten in rational notation as x to the 1/2 is equal to 4. I raise this value to the reciprocal, which is 2 over 1 is equal now to 4 to the 2 over 1. X to the 1 over 2 times 2 to the 1 gives me x to the 1. 4 squared is equal to 16. Last problem for the slide, square root of x plus 2 is equal to 3. I've already isolated the radical on this side of the equation, so I don't need to take any further steps. I'm going to convert this to rational notation. X plus 2 to the 1/2 is equal to 3. I take x plus 2 to the 1/2 and I square that value. So x plus 2 to the 1/2, taken all to the second power. At the same time, I need to square the 3. So if I square the left-hand side, I have to square the right-hand side as well to make sure that I maintain the equality between the two equations. I'm left with x plus 2 is equal to 9. 3 squared is equal to 9. Subtract 2 from both sides, and I'm left with x is equal to 7. Okay, last set of problems. I have cube root of x is equal to -2. So in this case, the radical is isolated on one side, so I convert to rational notation. X to the 1/3 is equal to -2. I take x to the 1/3 to the third power. X to the 1/3 taken to the third power. At the same time, I take -2 to the third power. This leaves me with x to the 1. This leaves me with -2 times -2 is 4 times -2 is -8. X is equal to -8. Next problem, I have the cube root of x minus 2 is equal to 1. I need to isolate the radical, so I'm going to add 2 to both sides. I have the cube root of x is equal to, I'm going to add 2 to both sides. 1 plus 2 is equal to 3. Convert to rational notation. X to the 1/3 is equal to 3. Raise x to the 1/3 to the third power, the reciprocal of 1/3. At the same time, I raise 3 to the third as well. This leaves me with x to the 1. So again, power of the power, 1/3 to the 3 over 1. I multiply the exponents together to get 1, and this leaves me with 27. Last problem, thanks for hanging in there with me. I've got the cube root of x minus 5 is equal to 4. Radicals isolated on the left-hand side. I'm just going to now, I don't need to isolate again, I just need to rewrite in rational notation. X minus 5 to the 1/3 is equal to 4. X minus 5, I'm going to take to the 1/3, I'm going to take to the third power. At the same time, I take 4 to the third power. This leaves me with x minus 5 to the 1, or just x minus 5 is equal to 4 to the third, which is equal to 64. I add 5 to both sides, and I get x is equal to 69. All right, that's it for solving radical equations. Both lesson and the practice. You can review if you need some help. Otherwise, we're going to move on with the chapter, and we're going to start talking about composition of functions and then inverse functions in the subsequent sections. So performing function operations, composition of functions, and then inverse of functions and then we'll be done with the chapter. Thanks for joining me on Ought in Math.